Alrighty, hello, we're back, and well, to Sudoku. Shocking, I know. Sorry. Today we're gonna do a fun thing, and by that I mean we're gonna fucking clean up. We have this puzzle here, this parody, which is the second of the two puzzles. The first one we did yesterday, which was Equilibrium, that I unfortunately kind of already know the trick for, but one, this is a 3-star, while Equilibrium was a 2-star, and two, I know less of this one than I do of the other one, because with the other one, I watched the whole video a while back. With this one, I only watched pretty much the very beginning of the Cracking the Cryptic video on it. So we should be fine, basically, is what I'm saying. The puzzle should still be fun, and there should still be some aha moments. But let's get into it. So, normal Sudoku rules apply. Place digits 1 through 9 in each row, column, and 3x3 box. So, standard Sudoku stuff. The 3x3 boxes are a little hard to see with all the stuff on the grid, but hopefully they shouldn't be too difficult. Aim of the experiment. Finks the rat, good girl over here, must reach the cupcake by finding a path through the maze. The path will be a snaking line that passes through the centers of cells without visiting any cell more than once, crossing itself, or passing through any thick maze walls. As well as moving orthogonally, Finks may move diagonally if there's a 2x2 space in which to do so, but may never pass through a rounded corner / end of a wall. So basically we're going to have to draw a path from Finks here to... This is wrong, I can tell, but we'll get into those rules later. To the cupcake. And we can't pass through any walls. We can't do something like this. Whoops. Can't do something like this, because that's passing through a rounded corner, like I said. But if there's a full space in which to move diagonally, which in this puzzle there's actually only this one over here, then we can do that. Yeah, that's how that works. Wow. Okay. One-way doors. Finks may only pass directly through a purple arrow if moving the direction the arrow is pointing. An arrow always points to the smaller of the two values it sits between. So that's why I said that path was wrong. So if we come over here, for example, we would definitely not be able to go there, because that's moving in the wrong direction. Good triangle. And also there's just the pointing to the smaller two values rule. So if this was an 8, this would not be able to be a 9. It would have to be smaller than an 8. And if this was a 4, for example, that would have to be smaller than a 4. So it'd be a 1, 2, or 3. Black currents. Cells connected by a black current, which are these, are in a 1 to 2 ratio. Not all possible black currents have been given. So that's pretty simple. If this was a 1, that would have to be a 2. If this was a 4, that would have to be a 2 or an 8. Easy enough. And then test constraint. In this experiment, the correct path will be a valid alternating parity line, i.e. any pair of adjacent cells along the path must contain one even digit and one odd digit. Let me just make sure. Okay, yeah. I'm recording. Good. And yeah, that's about it. So, I mean, that's pretty self-explanatory. You know, if this is the start of our path, if the cell's even, that one has to be odd, odd, even, and so on. So, let's get started. So, I'll say one thing. I know the trick to this puzzle, right? I'm not gonna beat around the bush. I've already said that I know it, but I don't know exactly how it's applied, right? So the idea of this puzzle is that if we only move orthogonally, if we don't ever take this or this diagonal, then the puzzle's going to be impossible because we're going to have the wrong parity when we get from Finks to the cupcake. Now, what do I mean by that? What I mean by that is that if you only move orthogonally through cells, if you think about it, this cell has some parity, right? Let's just call it purple. Whichever of these cells you move to, it's going to have the opposite parity. So that would be orange. And then whichever cell you move to is going to have the opposite parity from that, which is going to be purple. And then whatever cell you move to is going to have orange, and then purple, and so on. And you can see this kind of checkerboard pattern that's happening. People call them like bishop's moves, right? Bishop's colors. So however the path moves, it's going to move sort of according, Jesus, come on. It's going to move sort of according to these bishop colors. I mean, you get it, right? It's going to extend, extend, extend. And then eventually, we're going to get to the cupcake. And the cupcake is going to have the same parity as Sphinx. Now, that's only if we move orthogonally. Because, think of what happens if we move through here diagonally. So if we went through here, for example, which, again, that path's impossible, but whatever. Let's just ignore that. Then this will be orange. And now let's say we move diagonally. Now this is purple. And now let's continue the path. Orange, purple, orange, purple, orange, purple, orange. So now it's a different parity here in the cupcake. And that's the extent of what I know. For some reason, and I don't remember why, and thankfully I don't remember why, because it's going to make the puzzle more interesting. For some reason, we need the parity of the cupcake to be different than the parity of Sphinx. And thus, we're going to have to move diagonally through here at some point. Either like this or like this. But that's all I know. So, yeah. There we go. Now, I do remember the first question that Simon asked when starting this puzzle. And again, that's the only question I remember. So after this, it's completely, out the window. We know nothing. The question was, why can't things just do that? I don't remember what the answer was, but let's think about it. If things did that, then whatever this parity is, it's going to be the same as all those. And then these are going to be a separate parity. Now, that means this black current... What does that mean? Well, first off, that means these are gonna be odd, because there's 5 odd digits and 4 even digits in a Sudoku. Yeah, okay, so that's why it doesn't work. Because now, think about this. If this is odd, and it's on a black dot, it can't be a 5, a 7, or a 9. Because those don't have a pair in black dots, right? If it's 5, the other digit can't be a 10 or a 2.5. If it's 7, it can't be a 3.5 or a 14. But 1 or 3 do have pairs, but they only have a single pair. So if this was a 1, both of these would have to be 2s. If this was a 3, both of these would have to be 6s. That's impossible. So that's not our path. Definitely not. But Sphinx has 3 more options to start the puzzle. Well, 4 more options, actually. She could go halfway in this path and then turn. But I think that has the same issue. Yeah, it does. Because now these 2 are going to have the same parity. And this is going to have a different one. Yeah. It's a slightly different issue, but it's kind of the same issue in disguised. Imagine that, imagine that orange was odd. Then it would be the same issue, right? This would be a 1 and a 3, and then both of these would have to be the same number. But now imagine purple is odd. Well, if they were 3, if this is a 3, then this would be a 6, this would be a 3, and we have 2 3s in the same box. Same thing with this is a 3. Now if this is a 1, then this is a 2. But then this can't be a 1, so it would have to be a 4. But they have the same parity, and that's not allowed. And same thing on the other way. If this is a 1, this would be a 2, this would have to be a 4, and that's not allowed. So that's also not what Sphinx does. Which leaves us with... I was going to say 3, but actually 2 more options. Because the third option that I was going to say is she moves all the way up here. That's also not possible because here we have the same setup as down here. This is going to be some parity, and these are going to be different, and we're going to have the same issue as before. So instead, there's only 2 options. Either she goes over here, and then follows this path, or she goes over there. She doesn't do that, because now, look at what happened. Now we're stuck. Now we're in this little box here, and whatever way we try to escape, we're going to have to go through an arrow through the wrong direction. So she doesn't do that. She starts the puzzle off exactly like this. And I'm going to start drawing parodies. Again, I don't know what these parodies are. I don't know which of them is even, which of them is odd. I just know that they're different. Now, eventually we're going to have to get out of this box, because we can't go through that arrow, so we're going to have to go through here. We can't go down, because then we're going to cross our own path, so we're going to go up. And I can actually tell you what parody this is, because from here to here, we did not go through the diagonal, so this has the bishop's move thing that I was talking about. So this is definitely purple. And you can see that by just testing out both possibilities. Either we go through here, and then it's going to be orange-purple, or we're going to go through here, and this will be orange-purple, orange-purple. So either way, that's going to be purple. That is orange. That is purple. That is orange. Now from here, we're definitely going to have to get out of this box, so we're going to go through there eventually. And again, no diagonals in here, so I can use bishop's move to say that that is orange, and that is purple. Ooh, this is interesting. We're almost done with the parody of this box, I just realized. There's 4 oranges here, and 3 purples. So if you can get some info about these, then we're going to know which one of orange and purple is even, and which one is odd. Now, one quick thing we can say about this. Black dot pair is that one of them is even, and one of them is odd. If you think about pairs that can go on a black dot, there's 1, 2, there's 2, 4, there's 3, 6, and there's 4, 8. Out of those, only 1, 2, and 3, 6 work. But actually, yeah, well, out of nowhere, we actually solved what orange is and what purple is. Because, now think about this, what would happen if this was a 1? Well, these would both have to be 2. So this is not a 1. Now, what would happen if this was a 3? Then both these would have to be 6. And that's not true. What would happen if this was a 6? Both these would have to be 3, and that wouldn't work. So that's a 2. That's a 1. And now, purple is odd, and orange is even. I'm going to do... So normally I do orange for odd, and then a blue for even. So that's what I'm going to do. So I'm going to switch the colors up just to make things a little easier to understand. So now, yeah. So now oranges are odd. So all these digits here are odd. And all of those are even. Which is actually huge, because that's 4 evens in this box. So everything else is odd. Those are odd. This is a 1, 2, and then this can't be a 1 again. So that's 4. That's even. That's 4 evens in this column, making those odd. Which means we can't go up now, because if we did, whoops, we'd cross through 2 odds, one after the other, so that's not going to happen. We're going to go right here, and that's going to be odd. This is interesting. There's only 1 even in this column so far, so 3 of these are going to be evens. Don't know which. Let's see. Where do I continue from here? I can... what's gonna happen? Okay, I'm just trying to imagine what happens now if we go down here. Because if we go down, we can't go right. We can't go left here because we end up crossing our own path somehow. We can't go right there, so we'd have to go all the way down to here and then turn. Is that possible? That would mean that's even, 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 even. Odd, odd, odd. 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 Impossible. There we go. So that would be odd to finish off that column. That would be odd because of the path. And now we have the same issue as before. These are either both 1s or both 3s. There's no way for them to be different if they're in a sequence like this. So that's not what happens. We don't go down. We go right, actually, which still gives us a lot of info, because now we can draw that entire path. These are all odd, and these are all even. We still haven't actually used the info about the... Oh my god, I'm getting a call. Okay, never mind. It's not urgent. What was I saying? Yeah. We still haven't actually used the info about the fact that we need to change parities here. So maybe I would have been fine even if I didn't know that information. I think I would have, honestly. This is a fun puzzle so far either way, honestly. So now we have 3 options of where the path could go. It could go immediately left, it could continue down a little bit and then go left, or it could continue all the way down. It doesn't do that, I can tell you that much, because even, there's not 5 evens to play with, so it doesn't do that. Can it do this? That would mean it would turn here, it would have to turn there, it would have to turn there. It couldn't go up, so it'd have to go down. And then it could actually go, well, it can't go right, because then we're going to be in sort of this region of the puzzle that's kind of unexplored territory. And then how do we make it back to the cupcake? We've blocked off every route to it, so it wouldn't be able to go right. So we'd have to go straight to the cupcake, and I think that's impossible. Yeah, it is, because now this is even, this is even. Actually, that's 4 evens. That's fine. Wait. Surely you just, right? Yeah, there we go. Okay, cool. That's 4 evens, sure, but that leaves a black dot with 2 odds. And I don't know about you, but I don't know any pair of digits where one is twice the other and both are odd. So that's also not what happens. So instead we do go left here. And that is odd. Now there's a few options of what to do. If I can prove that this has to be odd now to not be the same parity as Sphinx, then I can prove that we don't go down. Well, we might be able to go down, but we don't cross these doors, because then we have the same issue as before. We're not going to be able to get into this little square here, because we are going to block off every path to it. How do I prove that? I don't know yet. Let me just mark some stuff. These are 6 and 8. This has to be sort of big. Not that large, but like this be sort of big. This is from 4, 6, and 8. That's from 2, 4, and 6. Does that work? Yeah, 4, 3, 2. Yeah, that works. That's not as much info as I thought it would be. I mean, I can say this is not a 1, and it's not a 9, so it's a 7, 5, or 3. Because it must be between these two. Now what? Not sure yet. We have 3 evens in this box, so there's only 1 more even in all those. Now this is where the puzzle gets interesting, eh? Where do I go from here? Don't know. Good question. Well, here's one thing. That can't be odd because of what we said before, right? If that was odd, that would be a 1 with either 2 2s or a 3 with 2 6s. So that can't be odd, so that's definitely even. I don't know how these work, though. And one thing I can say is that this is a 2 or a 4. I should have spotted that immediately, but yeah, this is a 2 or 4, and it's even. Because that's how these sequence of 3 black dots work. They're either 1, 2, 4, or 2, 4, 8. Either way, the middle digit's always 2 or 4. And these are from 1, 2, 4, and 8. I guess it can work, though. That's fine. What do we do here? How do I prove that this has to be odd? Well. Okay. Wait, that's interesting. There's 3 even digits here. So if this was even, let's think about this. If this was even, whoops, then where does the path come from? It can't come from the left, because if it does, then that's how the path ends, and this would have to be even, and that would give us 5 evens in this row. That's impossible. So the path would have to come from... Still imagining that's even. The path would have to come from above. And obviously we can't do that because we can't cross our path. So we'd have to do that. It couldn't do this because that means... Well, can it? Even. Hold on. I'm trying to think of the possibilities here. The simplest possibility is that it does something like that, right? And this is even. Oh, sorry. I'm dumb. It also can't come from above because there's 3 evens here already. So if we come from above, then that's also even, and that's 5 evens in that column. And thus, it's impossible for this to be even. So the cupcake is odd. And now we've proven that we must change the bishop's move, like parity thing. By the way, this is odd to finish off that row. And now we must get here. So that is a necessary part of the puzzle. We must get to that 2x2 square and move diagonally somehow. So now I believe we can prove that we don't go through either of these gates. Because if we do, we're going to block off the path to the cupcake. Just always. We're going to either end up at the cupcake with the wrong parity, or we're going to block it off. And that's bad. So we don't go through these gates. We don't go through that gate. So eventually we're going to go through here. Now I don't know if we do that immediately or if we do some weird stuff over here, but we'll figure it out. Actually, can I prove that we don't do weird stuff? That would be even, that would be even, that would be even. That's fine for now. Okay. So I can't prove that we don't do weird stuff, but I can prove that we're going to get here before we change the bishop's move thing. So this is going to have the same parity as that. It's going to be even. That's going to be odd. Path is going to continue through here. Those are even now. And that's odd. This is odd to finish off that box. Now what? Well, here's one thing. No, never mind. I was going to say bullshit. I was going to say, as soon as we get to the 2x2 square, we need to immediately move diagonally. But that's actually not true. We can do something like this, and that would be completely valid. So I'm just thinking for a second. If we do that, these are going to be even. These would be odd. And then what happens? I'm not sure, actually. Well, one thing I do know is, now how do we get to the cupcake? We can't come from above at all, because we know we don't cross through these. So we're going to have to come strictly from the left, which means we're going to have to go through here, which means these are different parities, which means that's a 1, that's a 2, and that's a 4. And now this is even. That's 4 evens in that row. This is 6 and 8. Now those are all... Ah, shit. I fucked up, actually. Oh, sorry. There's still one more possibility that I didn't think of. Coming back through here, and then coming down through there. Which now, I think I just proved that that's exactly what we're gonna do. Or, you know, coming down through there, but either way. Shit. I think we're gonna have to come through here now, eventually. Because the only other option is doing that which I just said. But that's impossible because of what we just proved. It would create 3 odds in a row, or 4 odds in a row here, actually, and that's completely illegal for the path. So we don't come from there. Which means we do come from one of these, which means we're going to have to come from one of these arrows. But that's not where the path is headed right now. The path is headed over here to do the polarity, the parity change. So instead, we're going to have to come back to the arrows, and the only way of doing that is by coming through here. Now, I don't know which arrow we're going to take, but we're going to do that for sure. And that's going to be after we change the parity, which you can see by the fact that this is not the same parity as that. But either way, these are still all even, and this is odd. And now the path definitely doesn't do a loop-de-loop, because that would be crossing our own path. So this path continues straight. These are odd now. To finish off that box, which means we might be able to move like that. Don't know yet. We definitely can't come to this square from there, because that's wrong, so we're going to have to come from here, which means that's odd. Can we come to this square from here? Weirdly enough, yes. There's a very specific situation in which we might be able to do that. It's if we do something like this. Which, honestly, that might just be correct, knowing how Marty is. Oh, now this definitely doesn't go down, so it goes at least to here, making this even. That odd. That's 4 evens in this box, so those are both odd. Oh, that's 5 odds in this column, so those are all evens. These are 6-8 pair. Which means these are 2-4 pair. I feel like we're going to have a lot of these pairs to deal with eventually, but that's for later. That's 4 evens in this box now, so those are both odd. So now the path definitely doesn't move like this in this part, so we know how to complete that. It's like that. Still don't know how to complete this part of the path, but we'll figure that out in a second. I'm sure. How do I continue this now? Are we forced to use this part of the puzzle now? Because if we don't... What the heck did I just do? If we don't... Then what does that mean? No, we're not actually forced, because we can do that. Ah. Well, can we, actually? So that would mean this is even, this is even, this is even. It's completely fine. It's the correct amount of evens for that row, even. Well, what happens if we do use that part of the path, though? That means we have to go all like that. That's... That's before the parity change. Which would mean this is odd, this is odd, this is odd, this is odd. Oops, wrong color. These would be all evens. And now I think it's impossible. Because now how do we get to here? Either we go down through there. No, that's possible. Hold on. Wait a second. We can't come in from the left because that's already 4 even, so this would have to be odd. So we'd have to come in from down. And then either that happens or that happens. Whoops. That can't happen. Because this would be even, and there's already 4 evens in that row. Can that happen? This would be even. This would be odd. This would be even. Making this even. Taking that off. That's possible. God damn, man. Oh. No, it's not actually possible. Because, sure, this is odd, but now this is even, and now this is even, because it would be a 1, 2, 4. So that's already 4 evens. That can't be even. Okay. Now I need to walk all the way back through that again to make sure that I thought of every possibility. So if we ever go into this part of the maze, then we're definitely going to do that much, at least. Now, that part of the maze we would enter before doing the parity change. Right? I think that's for sure, right? Oh, by the way, this is even. I didn't notice that. Sorry, that still has even in that row. Which means that's odd, which means this is actually how the path connects. Sorry, back to thinking about this. Yeah, no. This part of the path would definitely exist before the parity change. Which would mean, by the old bishop's moves, this would be odd. Which makes these all odd. Those are all even. Since this is a 1 now, this is a 2, and this is a 4, making that even. Which would make both of those odd. But now, we definitely need to move a diagonal here. And it can't be this diagonal. Shit. I didn't think of this possibility. Well, it's still impossible, because now that would be even. And that's already 4 evens that row. The other possibilities are this, which violates the path. This, which means this even, and it also violates. And I think that's everything. I think those are all the shit. One more. Well, no, that's impossible because this. Yeah, okay. Okay, so I think we've proven, if I didn't miss anything, that this cannot be on the path. Let me just redo what I did over here. That's odd, and that's even. And this is how the path goes. Okay. Which means if this is not on the path, then this is not, this is not, this is not, this is not. Which now, now there's less ways for this to happen. In fact, now I know where we move. We don't go left, because if we did, then we'd either go left here and cross our own path, we'd violate the one-way door, or we'd go into prohibited zone. So we go down. Can't connect there quite yet, because we haven't done the parity change, so we go down again. That forces this to go down, forces this to go down, forces this to go down. And now the only problem is, I don't know how these connect. It could be like that, or like that. But I do know they're parries. That's now odd. Both of those are even. Both of those are odd. 4 evens there means this is odd. This is even to finish off that row. This is even to finish off that row. And now... no way. Well, now that's 4 evens here. So these are both odd, which, if this is odd, it means it's a 1. This is a 2, this is a 4. So it's definitely even. And now, yeah, and now this can't be it, because this is odd. So this must be how it happens. That's even. And it is a 6 or an 8, because that's a 2 and a 4. Okay. It's insane how we haven't gotten basically any digits yet. But I'm pretty sure they're just gonna come, like, flying in as soon as we're done with the path stuff. Now, what? Well, now all these are odd, because we have 4 evens in that row. So all those are odd, which means we definitely don't do this to finish off the path. So the path must come from up, must turn here. Might still be able to, jeez. Might still, what is going on? Might still be able to do this weird thing. Could, honestly. Don't see why not. I just know it goes at least to here, which means these are both even. And that's odd. That's the last thing on this column is an even, which means now we don't go down, so we go straight up, and then we connect like that. And that's the path, actually. That's the whole path done. Which means now it's just finishing up the coloring and getting digits in. So that's odd to finish off that column. We can get rid of these X's now. They're not very useful anymore. Get rid of that. These are 2 even, so they're either a 2-4 or a 4-8 pair. They definitely contain a 4. This is gonna be 1 odd and 1 even, so it's either a 1-2 pair, which is not like that, or it's gonna be a 3-6 pair. Don't know which. I thought the puzzle was just gonna crumble under its own weight, but it hasn't yet. This is 6 or an 8, which means this is a 2 or a 4. This has to be pretty small. Actually, it has to be pretty... Never mind. It has to be kind of large. It doesn't have to be that large. It can be as small as a 3. I was thinking about it backwards, my bad. This is not going to give up as easily, is it? Wow. Yeah, I don't think we're going to get these colors until we do a little more thinking about the Sudoku. I'm pretty sure that's the path. Yeah. So, I mean, yeah, now we just have to figure out what happens. Just in general. Let's see. Confused. These arrows are definitely going to do a lot of work, but I don't know exactly how. These can't be 1s, so they're from 3, 5, 7, 9. That can't be a 3. And that can't be a 9. don't know what that means. This is not a 4, because 4 is in there. So this is from 2, 6, or 8. So are these. This must be bigger than that. And it's even. So if this was a 6, that would be forced to be an 8. Which would make that a 6 and that a 2. Which would do a lot of stuff, actually. But that's only if that's a 6. Now if that's not a 6, then that's odd. Which would mean that's even. Which would be a lot of info, actually. Well, not that much info, but it would be it would finish off the coloring at the very least. If nothing else. Let's see. I mean, I hope I didn't make any mistakes in the path. I really, really do. Just make sure that what I drew is actually correct. At least rules-wise. Yeah, that's right. So, I don't know. Yeah. Let's see. Turns out knowing the quote-unquote one trick was not enough to save me from being bad at Sudoku. I jest, of course. I'm fine. This can't be a 2, because if it was, this would have to be a 1, and it can't. So 2 isn't one of those 2. Which means these aren't 2s. These are from 4, 6, and 8. That's not 4 either. So that's pretty big. Which is good. That's what we want. If that was an 8, that'd be forced to be a 9. Which it can be. Nothing's stopping it. It's pretty restricted, but it's not that much. If this is a 3-6 pair, that just means that's an 8. That's fine. That's completely fine either way. If this is a 6, that just means that's not a 6, which means that's odd. Which means that's even. Darn. Well, 6-8 pair actually puts a 2 here. That's a digit. That's something we haven't seen in a long time. This is from 6 or 8. The other 6 or 8 is somewhere in here. I don't know which one of those it is. Ooh, 6-8 pair there puts a 2 here. Getting a 2 out of there. Getting a 2 out of there. Getting 2s out of those, which is huge, because now this is a 4-8 pair. Which gets 8 out of there. Four 8 pair puts a 6 here, which puts 6 out of here. Which does what? Don't know. Is that our correct so far? Yeah. 6-8 pair and a 2 there puts a 4. That's not a 4. This is a 2. Which means that's not a 2, which means that's not a 1. So this now is a 3-6 pair, making that a 2, making that a 4, 2, 2. Okay, we're getting some stuff. 8 there, 4 here. This must be bigger than a 4 and odd, so it's a 5, 7, or 9. This is whatever, 3, 5, 7, or 9. I guess I'll mark that, whatever. This is a 4, 6, or an 8. Well, it's not a 6 actually. It's a 4 and 8. This is a 4, 6, or an 8. It's not an 8 because it has to be smaller than another thing. So that's from 6 or 8. Which means that's an 8, 6, 4 there, 8 there, which is huge. because 8 must mean that's a 9. Putting 6 there and 8 there. A 6 here. 6, 8, 8, 6. Not a 9. These don't tell us anything quite yet, but surely soon. This is smaller than 6, so it's 1, 3, or 5. It's not 1. This is from 3, 5, 7, and 9. These are 4 and 8. This is 4 and 8. These are... I broke something. No, I didn't. Sorry. I'm saying these are from 2, 4, and 8. That is just a 4, actually, which makes that an 8, 6, 4, 2, 8. Which now puts a 3 there, which means that's odd. Putting an even there, an odd there, and an even there. Just finished off the coloring. Pretty cool. That's not a 3. The only odd digits we have so far are these 2 ones. Wonderful. That's an 8 to finish those evens off, and that's a 4. And suddenly, that's all the even digits. Now we gotta think about the odds. 6 is not bigger than 7. That's all I know there. 4 is bigger than 1 or 3, yeah. And, yeah, now I've marked all the arrows, so now it's literally just Sudoku. Which unfortunately is the part that I'm bad at. And unfortunately it's the part that I'm just going to use the, pencil mark, like, annotation thing for, because, I mean, I've said it before, I don't know, I just don't have that much fun just looking for the missing digit, the video game. Well, one thing I could say is that's not a 1. These aren't 1s. So the one in that row is there. This is 5, 7, or 9. These are from 3, 5, 7, or 9. These are from 3, 5, 7, or 9. This is from 3, 5, 7, or 9. See, I'm sorry, it's just not that fun. 1 in that box must go there. 1 up here must go there. 1 in this box. Could it go there? Yeah. Not great. These are from 3, 5, 7, 9. Guess what these are from? 3, 5, 7, 9. That's not a 9. 1 in this row goes there, which puts a 3 there. 3's come out of those. 5 is not bigger than any of those, so 5 comes out of there. 3 comes out. 5, 7, and 9 triple puts a 1 there. This is from 3, 5, 7, or 9. These, guess what they're from? These are actually from 5, 7, and 9. Because they see 1 and 3. So that's a 3. That's not a 3. That is a 5 now. Good. That's a 7. Means that's a 9. That's a 5. Now we're, I think, done. 7 goes there. 5's come out of there. 3, 7 pair means these aren't 3s and 7s. That is a 3. That's not. It's not 7 or 9. 5 or 7. 5. It's put in there. 5s aren't there. 5 and 9. Let me just check a thing. Yeah, we're still recording. I just realized that I never actually checked out what the issue was with my hard drive yesterday. So it's a good thing that it's still recording, because it was very possible that it wouldn't have been. That would have been bad. It's from 5 and 9. We're basically done. This is 5, 7, or 9. Can't be a 9. There. 5, 9, 5, 5, 9, 7, 9, 5, 3, 9, 7, 3, 7, 9, 3, 5, 7, 7, 3, and to finish it off, a 9 and a 1. Very cool puzzle. I enjoyed it a ton. Sure enough, it took me 50 minutes, even with quote-unquote knowing the trick. And again, I didn't know that much. So it was still fun. I had a lot of fun with it still. It was still very, very good puzzle. Experiment completed successfully. Cells visited 52, blackcurrants eaten 1, one-way doors used 6. Finks grew in confidence using the one-way doors, and did not hesitate to go out of her way in order to find a place to move diagonally, thereby achieving the necessary parity shift. Yeah. I have more faith than ever that next week's landmark experiment will see Finks secure her place in the history books. And thus she did. And in our hearts. That was great. That was really fun. I think with a little more time, I would have been able to do this even without sort of knowing the trick. And even then, I still proved it, right? It's not like I just used it blindly. I still went through and actually proved why that had to be the case. That this couldn't be even. And thus we had to do a parity shift over here. But yeah, that was very fun as usual. Let me just do this. Digits on the path in row 6. Those would be 6, 9, 5, 1, 8, 7. 6, 9, nice. 5, 1, 8, 7. And that's it. Cool. Which now means we're done with the 2 puzzles that I sort of knew the tricks for. Leaving only 2 more puzzles. Discontinuous and censored, which I know nothing about. I couldn't even know anything about censored because the video for that on Cracking the Cryptic is not even out. Discontinuous does have a video, but I did not watch it, and I will not watch it because I do want to do it eventually. I don't know if soon it's 4 stars, which sort of scares me, but I do want to try it. It looks fun. We'll see. We'll see. I'll do them out of order, as I sort of have been doing. And I'll do censored first. Soon-ish, maybe. But from there, we'll see how it goes. But yeah, today's puzzle is very fun. Enjoyed it a bunch. Marty is a great constructor, as always. I have much faith in him to make puzzles. Let me actually look at something. Yeah, no, he's made a few more puzzles already. After the Rat Run series, and I mean he made a few during them as well. It's not like he was only doing Rat Run. These are quite hard though. These are 4 stars. What the heck? What am I looking at? Brother. Non-venomous? Oh, snake? Ugh, brother. Huh. Yeah. Maybe one day. The train and the fly. No clue. Yeah. Anyway. That's it for now. Yeah, nothing else to say. I'm still terrible at finishing these videos. Good night.